Hello everybody, it's William here. So let's continue our journey of deep learning. So let me rename it. If you're new here, it's a series video about, as the name suggests, deep learning. And in the previous video we talked about neuron, and mainly the sort of an input section of neuron, and at the neuron here we need to sort of add all that up, and I'm going to show you guys how it's done, and then I'm going to show you the next step, which will be the activation. Okay, so let's get started. And if you haven't subscribed to my channel or think my video is helpful, you can give me a thumb up and subscribe to my channel. I'm really hardworking. I nearly update video every day. So mainly about programming and artificial intelligence, game development, and then all sorts of interesting things. Okay, it's just anything about technology. So let's continue. So remember, we got a lot of inputs. Let me just rewrite that for you. Okay, so we got a lot of inputs, and then we got our neuron here. And did I spell that correct? Neuron. Okay, and then we got outputs. So basically just 3 steps: step 1, 2, and 3. So input, we got a lot of input. So x1, x2. Let me just use x because when we use Python or any other deep learning framework, we are going to use x to represent all the input and y as output. This is sort of like the convention that people in the deep learning field just use. Okay, so m and all that, when we sort of sum all that up as the neuron, we need to sum all that up. So this is a summation, and from 1, which means from here, and all the way add sum to the last one, which will be m. Remember, we got different weights of different inputs. Okay, so we got weight 1, weight 2, and all the way up to weight m. Okay, because we got m inputs, so we need to use the weight and multiply by this input, and we're going to sum all that up, and we got this result here, and that results will be put into a activation function to make our judgment whether to activate that neuron or not. You can sort of think the activation as a trigger, like whether you fire or not. Once you fire that, and you're going to learn from the thing. Whether you do not fire, you sometimes don't learn, and sometimes we use a sort of an activation function that is pretty hard for you to fire or to learn on some data set. So we sometimes use a sort of a leaky function, and we will talk about that later. Okay, so just to sum all that up, we use all the inputs, we assign all this weight to that input, and we sum all that up. Okay, that's the previous 2 steps, and we're going to introduce you guys to the last step, which will be the activation function. And let's look at the third step, which is the output. So from here, neuron to output, we get an activation function, and the activation function basically, I think most of the time, in my tutorial at least, I'm going to classify that into 2 parts. The first is a sort of a threshold. The threshold is that whether it's 0 or 1. Okay, so once you step over the threshold, you got 1, and we sometimes call that the rectified linear unit function, or ReLU, and I think it's the most commonly used activation function because it's pretty simple, right? And any negative value to 0, and any positive value stay the same, something like that. So let me show you guys. Okay, so First, let me introduce you guys to value. So basically, it's just a function x equals to max, whether you got 0 or x. Okay, so just any negative, you just got 0, and any positive, you just be itself. Okay, but yeah, but this is a little bit extreme. The reason for that is that any negative value just become a 0 that sometimes become pretty hard to trigger. So in order to improve that, if you use the value model and you realize that your machine learning model is hardly learning based on the specific data that you feed it, you might need to use a sort of leaky value. Okay, leaky value is just you just change that a little bit. Okay, so you max that. Instead of using 0, you can just 0, 0, 1 x, something like that. So you sort of it is pretty small based on this coefficients, because they sort of shrink it to a little bit, but you still give it a value. You don't just completely make it 0. Okay, and then x. Okay, so that's the way it's leaky, as the name suggests. Yeah, but yeah, this is just a sort of remedy to alleviate the something we call the dying value problem. So the value, if so all that is negative, this just a neuron just died because it always stay inactive and unable to fire that neuron, and we can't learn from it. Okay, so in this way you can accumulate value from that, and that's what I classify as the sort of threshold function. And of course we got probability. The most important one is sigmoid function, and of course I think the hyperbolic tangent function, sometimes we use tang. Let's call let me write that for you. Hyperbolic tangent function. Okay, so this is a continuous function. So this is more like the probability you want to get. So for example, you want to get the prediction of whether tomorrow will rain or not. You need a probability, or you have 19% of so the confidence that tomorrow will have a rain. You need to call the continuous function, and this function is better understood by let me draw you a graph about it. Okay, so essentially, let me go clear that. Essentially, if you are using sort of threshold, you will get the y, and not use y, but rather use the this is not x, this is like the summation of that. Okay, so summation m and adding the weight and x, something like that. So just plug in the previous input summation into that, and you got the function. But you got an idea. But let me just erase that, just to make it much more clear. You just have a vague tuition about that. The threshold is like all that is 0, and once you pass a certain threshold, you're going to trigger that. Okay, so you're going to trigger that. You just jump it up, and then just be a value, or then maybe go up, something like that. Okay, this is just a threshold. But if something like the sigma or probability, most of the time we use sigma. Okay, sometimes we use tangent, but sigma is pretty typical, pretty classic. It's like something like this. And if you look at it, sometimes nature have a lot of things that happen using conform to the sigma function. For example, some species, if you let it grow in a restricted area with limited food, the number of species grow, so the bacteria grow will be like this. They can't grow indefinitely because the resources is limited. Okay. Yeah, that's a good way to solve the problem of percentage. Yeah, I think that's a pretty good way. This is a lot like fire and trigger certain thresholds, so as the name suggests. Okay, so they just got a basic idea of what is going on. Remember, we got this input, right? We got all this neuron input. We got this neuron here, and we're going to get as an output, right? This is where the activation function lies. Okay, so you got all the sum it up, and you're going to feed that into the activation function to make your call whether to fire or not. Okay, and yeah, I think that's pretty much about the neuron, and this is the structure of neuron. And I think this video is already pretty long, so in the next video I'm going to share with you guys how this neuron actually work. Okay, so you got all this jargon about the input, the weight, the summation, the activation, and all the outputs. But how does neuron actually learn? If I give you a table of data that have a lot of variable in it, how can you put this data into this pretty fancy multi input value and got a hidden layers neural network, and how does it learn from it? How does it adjust the output to learn from all this data and make good prediction? That's what we will solve in the next video. So if you're still there, I know it's yeah, because we haven't coded yet. Just a brief tour of the concept. So it's not so interesting, but I guarantee you in the future we will be much more excited to share with you guys a lot of real data and real coding using our AI deep learning model. Okay, so if you're still there, my name is William, and if you think my video is helpful, please give me a thumb up and subscribe to my channel. And yeah, thanks, guys. Bye.